I'm Tyler Thompson, aka Space Explained, and welcome to another video. I recently was talking to some friends about space and gravity and realized that a ton of people have the misconception that gravity just ends when you get into space, and that if you get into space, you are automatically orbiting Earth. And I've found that they can be pretty stubborn about believing the facts, so I decided that I want to end that misconception and spread my knowledge of orbit, microgravity, and some other misconceptions about space. Anyways, let's get started. First off, let's cover how orbit works. So, Tim Dodd, the everyday astronaut, likes to say, to get into space you have to go up, but to stay in space you have to go sideways, really, really fast. Which is a pretty general statement that pretty much sums out how orbit works perfectly. It does, however, miss all the juicy science and orbital mechanics that go into getting into orbit. Most orbital rockets are only going directly up for a very short period of time after they leave the pad. They start pitching over downrange almost immediately. This is so that the first stage can give the second stage as much horizontal velocity as possible while getting it out of as much of the atmosphere as possible. To get into orbit, you also need to be going at least around 10 times the speed of a bullet in a horizontal direction. This is so that the centrifugal force pulling you away from the planet is equal to the force of gravity pulling you down, which means that they cancel each other out. This is why you don't feel any gravity when in space. Not because gravity doesn't affect you anymore, but because the centrifugal force pulling you away from Earth is equal to the force of gravity. In fact, when you're in space, you have about the same amount of gravity affecting you as if you were just on the surface. Now, you may be wondering how suborbital vehicles like Blue Origin's New Shepard that barely cross the Kármán line or the boundary to space have zero gravity. And this is where the biggest misconception of how gravity works comes into play. So, there's virtually no centrifugal force affecting the capsule, since almost all of the velocity is vertical. But another factor of feeling weightless is that there's virtually no atmospheric drag, meaning that you are completely free-falling. Now, this is where things get trippy. Imagine you are skydiving and suddenly all the atmosphere is just gone, except you can still breathe and function normally, obviously. You would feel completely weightless and actually feel like you're floating. Imagine it like this. Earth has a center of gravity, and that center of gravity is an exact point. So if you removed Earth from the scenario and kept the gravitational field, you would just have a gravitational field with nothing in it, obviously. So it would basically just be a black hole. You just wouldn't get sucked into an abyss. Now imagine you're heading towards this center point of gravity at a constant rate. As you get nearer to it, you start to feel the effects of this gravitational force. You accelerate towards it, but since there's no atmosphere or ground to push you up against this gravitational force, you keep going towards the center and through to the other side. You continue through to the other side, then you start to decelerate. So theoretically, you would leave the gravitational field at the same velocity that you entered it, meaning a net zero acceleration. The reason you would feel weightless when skydiving on Earth without an atmosphere is due to, as I mentioned before, there being no atmosphere to slow you down and push against you. Now imagine we had a floating surface around the gravitational field with an infinite strength, and you landed on this surface. All of a sudden you now feel 1g of gravity. This is because there is a surface pushing up against you and keeping you from going to that center point. But you always want to go towards that center point, so you will always feel 1g of gravity. Now, say that we move this surface closer to that gravitational point. You'd all of a sudden feel more gravity because it's closer to this center point, and therefore the gravitational force is stronger. Move it farther away, and there would be less gravity. So going back to orbits and why astronauts feel weightless in orbit, what the heck is centrifugal force anyways? Well, you can think of it like when you go to the park and you get on one of those merry-go-rounds, and as the person spinning it spins it faster and faster, you feel like it's getting harder and harder to hold on, and something is pulling on you. That force is centrifugal force. Centrifugal force has been looked at for many years to use artificial gravity because you can produce it using a spinning structure. It is basically the outward force associated with rotation. Also, when you enter interstellar space, you are never in absolute zero G. There is always very small amounts of gravitational force being exerted on you, but they are just way too small for you to ever notice. So, this, going back to what I said before, is because gravity doesn't just end. It stretches out for light years, just getting weaker and weaker the farther out you go. Anyways, this week in space, we finally saw the SN-15's test flight. Woohoo! It lifted off and ascended into the clouds similarly to how SN-11 lifted off in the fog, so no one really got any good views of it except for SpaceX. They got some amazing footage of the launch, and I even discovered one of my favorite views on Starship, flap cam. I love how you can see the flap actuating with and the camera going with it. It's so cool. We can also see that SpaceX decided not to light Raptor number 66, leaving 61 and 54 to carry SN-15 down to the ground. This also proved out the redundancy of Starship's landing burn. There may have been an in-flight issue with number 66, so they just decided to not turn it on just to avoid another SN-11 scenario. It had an amazing ascent, belly flop, and then flipped to vertical before touching down softly, albeit right on the edge of the landing pad. A small fire started at the base of the rocket once it landed, but since it had so much space between the engine skirt and the ground, due to landing so soft, the fire suppression system was able to get the fire put out before SN-15 pulled an SN-10 and blew up. After 4 unsuccessful landings, I'm sure that SpaceX is glad to be able to say that the flip and landing maneuvers work. On top of that, we saw the launch of Crew 2, the second operational crew rotation from the U.S. soil in 11 years. And on top of that, we saw the return of Crew 1, which went flawlessly. We then saw a triple rocket launch with Ariane Space's Vega rocket lifting off first, followed by China's Long March 5B carrying the first module of their brand new space station, and ending with the SpaceX Starlink mission. The fact that we are at a point where we can witness 3 rocket launches within 2-ish hours of each other is just amazing to me. When we then saw a Falcon 9 launch carrying more Starlink satellites up on Star Wars Day, May the 4th. Which I think is awesome because the Falcon series of rockets were named after the Millennium Falcon. I'll wrap up this week in space segment with NASA's Ingenuity helicopter, which just took off for its 5th time. It's just amazing to see that something is so normal on Earth be achieved on another freaking planet with 1% the atmosphere of Earth. Also, NASA's Perseverance rover has a module on it called MOXIE, which stands for Mars Oxygen In Situ Resource Utilization Experiment, and it recently did a test run and produced around 5 grams of oxygen, enough to breathe for about 10 minutes. It made oxygen from the mostly carbon dioxide atmosphere on Mars by splitting the carbon dioxide molecule into oxygen and carbon. This experiment has paved the way for the future long-duration Mars missions, which will require a sustainable oxygen supply. Anyways, all my sources are in the description below as always, and you can follow me at SpaceXplained on Twitter, and the same thing goes for Instagram. I also recently started a website which I'm calling SpaceXplained Website V1, where I post all my scripts and you can learn just a little bit more about me. And it is also linked in the description. Make sure to like, share, and subscribe, and do whatever you can to help me end the general public's ignorance towards space. I'm SpaceXplained, explaining space like never before.